Okay, anytime.
Our higher output block was bored to a finished size of 4-inch 155 thousandths. To arrive at that dimension, first we took a look at our fact sheet from our piston supplier. The pistons for this engine were supplied by Wiseco. Here is their fact sheet on their pistons. It gives us everything we need to know about our piston and also how to check them. They have a suggested piston-to-wall clearance of 4 thousandths. Please note that it is suggested clearance. Other manufacturers will read suggested minimum clearance. On those type of pistons, you usually want to go 1 thousandths larger on your piston-to-wall clearance. However, they are not mentioning minimum clearance here, and we will use their 4 thousandths clearance in our engine. Also, according to Wiseco, to properly measure the piston, we must measure it at 1 inch 30 thousandths below the bottom of the oil ring and at 90 degrees to the piston center line. Once again, we'll measure 100 thousandths, 1 inch 300 thousandths from the bottom of the oil ring down the skirt to this area. To do that, we'll use a caliper set at that dimension. The location is indicated by the black dot. We'll also do the same on the opposite side of the piston. And note that these marks are perpendicular to the pin center line. Using our micrometer at these locations, we come to find that their piston measures 151 thousandths. That tells us that boring the block a true 30 thousandths oversize to 4-inch 155 thousandths will result in our 4 thousandths piston-to-wall clearance. Also, please note that all the pistons in the set should be measured in this manner. If the pistons vary more than 1/2 thousandths of an inch, then each piston should be marked for the cylinder it is going to be used in, and all cylinders should be honed equally to give them our required 4 thousandths piston-to-wall. Piston preparation for our applications are quite simple. It requires inspection for sharp edges and burrs and their removal. Sharp edges and burrs cannot be tolerated on the pistons. Let's take a look at the piston for our higher output engine. Once again, the quality of workmanship has been reflected in their cost. But we'll notice that all sharp edges traditionally found around the valve reliefs, around the dish and the piston, have all been broken and slightly polished. This is good. We'll notice on the skirt there are no burrs along the side of the skirt by the edge of the piston at the bottom of the skirt. If there were roughness here or burrs protruding from the bottom of the piston skirt, they'd have to be removed. We'll also notice that along this area, they've left the edge relatively sharp. This is advantageous because it helps to remove excess oil from the cylinder walls. This piston requires no extra work to prepare it for our application. Looking at the piston for a street application, we'll notice that around the valve reliefs, we have very sharp edges. These need to be removed. The easiest way to do that is to just use your triangular scraper or a similar tool and lightly break the edge, followed up by blending with a little bit of 320 emery cloth. This will give you a satisfactorily smoothed out edge. Also, looking at this piston, we found if we rubbed a tool along the edge of our finger, right in these areas, we found a burr projecting upward from the back beyond the face of the skirt. We remove this burr by using just the emery cloth at a very shallow angle. We don't want to dull this edge, but we don't want to have any projection from it. And for our application, this preparation will be adequate.